Y'all doing okay today?
Yes, sir. How are you?
Good, doing all right. Handing out your little popsicle sticks I promised you last time. So just share that pen. Everybody take a stick, put your name on it. I'm just going to put these in here in case someone else shows up. Here, y'all can share right here, right? There you go. Come on in here, excuse me. Were there any questions over the homework?
Yeah.
Yes? Okay, I keep doing that. All right, so which problems were
20
you?
and 21 for the word problems for fractions.
Uh-huh. Which one?
20 and 21.
The chocolate one?
Oh, no, just 21.
Is that, 21. How many 3/4 cup servings are there in 2/3 cup of yogurt? That one? Okay.
He told us not to do the linear equations, but I still went ahead and did some. I might have.
Yeah, we'll talk about that
Okay.
today.
All right, yeah, that's
Ah. All right, so the question is over this one right here. Okay. And then there was a few others, right? Okay, we'll get to those in a second. All right, so this one is asking how many 3/4 cup servings are in 2/3 cup of yogurt. So I realize the fractions probably cause an issue, just kind of gets your brain not happy to start. What I like to do in problems that involve numbers that are not nice is to kind of make up my own numbers. Just think about the problem if it were asked with better numbers. So you could say, let's say, change this, how many, 2 cup servings are there in 8 cups of yogurt? Okay, so if you read it that way, how many 2 cup servings are there in 8 cups of yogurt? Or in 8 a cup of yogurt? What? Yeah, okay. So how would you do this? Does that help at all? No, it doesn't help?
So I had my buddy help me in the way he was doing it, because I did it and it got to the point to where, so he got the answer and he got it to 10 on the bottom, but he couldn't explain to me how he got 10.
Okay, I'll get to the actual work for this problem in a second, but I'm changing the numbers because I'm hoping by changing the numbers that the problem makes more sense to you. Because you need to know what is the operation you're going to do between these numbers. Are you going to be adding them, subtracting them, multiplying, dividing? What are you going to do? So if you say how many 2 cup servings, so how many servings of 2 cups are in 8 cups of yogurt? So what is the actual operation that you're going to do that? You're going to divide. You're going to divide what by what? What are you going to? So how do we say that? We're going to take 8 and divide it by 2, right? That's how you would do this problem if it were like this. Does that make sense?
Yeah.
Okay, so if I were doing this problem, I would just go, okay, 8 cups, I'm going to divide it by 2, that's the servings. That would give me 4 cups. 4 servings. I would have 4 2-cup servings. Make sense? But those aren't our numbers, right? Yeah. But it's the same process. So instead of 8, what do I have? 2/3. That's how much yogurt I have. And I'm going to divide that by my servings, which are, what? 3/4 of a cup. So do you see I'm doing the same exact operation? It's just now I'm using the numbers that were given in the problem. Does that help? Okay, so how do we do this? This is the same as 2/3 divided by 3/4, right? That's what that means. And so you got to flip it and multiply. Flip, when we say flip, we mean flip the second one. So this is going to be 2/3 times 4 over 3. Division becomes multiplication, then we go straight across. Unless we can reduce, which in this case, nothing reduces, right? So on top we get 8, and on the bottom we get 9. 8/9 what though? 8/9 servings. Yes?
You do 22.
Yeah, I'm going to do one over here and then I'll come back to that. Can we get all those sticks? Let me collect those. You need a couple of sticks over there? Let's see here. Anyone else need a stick? Do you mind taking that back there? Just one. Thank you.
It might be sort of difficult if I went up there.
Yeah. No, it's just I'm going to call on you from this
Okay.
and just ask you to contribute your thoughts.
This one's extra.
What's extra? Thank you. Good. Okay. And you can just leave those Sharpies on the table. I'll get those after class. So I have everybody's stick. All right. So remember, this is not to like embarrass you or freak you out. It's just I want to get everyone engaged in the class. So while I'm working through a problem, I'll be like, oh, okay, well, you know. And the problem is you always have like the same people answering. You know, the same person keeps on answering. So this will kind of help me distribute the load and make you pay attention. Well, it won't make you, but hopefully it will encourage you to pay attention. All right, so what was the one that you had, sir?
Well, if you want to keep doing the word problems, because I think we had another word problem.
Okay, what other one did you want?
I think somebody over there.
Oh, you want to do that? Okay, what word problem did you have, sir?
22.
22, the one right after it? Cupcakes? So I was really hoping today that I would come in and you would have questions about the word problems. I was really hoping that would happen because I didn't really go through them and I wanted to see how you would handle them. Because these are probably, even though the problems aren't realistic when you read them, I mean, this is the part that's the most real world because you want to be able to solve problems, right? Critical thinking. All right, Sheila was making cupcakes for the school parents' student dinner. In the blender, Sheila knew that she had to put in 13 2/3 ounces of ingredients. She had to mix them together, all right? After she was finished, she poured the mix into 2 1/4 ounce or 2 1/4 ounce cupcake tins. How many of these cupcakes would one batch of this mix make, and how much of the mix would be left over? Okay.
I got as far as 6 pounds, but I couldn't get the fraction part.
Okay, so again, maybe some easier numbers might help us figure out what we're supposed to do. So instead of 13 ounces, I don't know, let's just go with like 20 ounces. All right, so she's got 20 ounces of mix in a bowl, right? She's going to mix that all together. And then from that, she pours the mix into, what do you want to use for the cupcake tins instead of 2 1/4? 2. All right, let's just go with 2. So let's go with 2. All right. Then how many of these cupcakes would one batch of this mix make? So she's got the 20 ounces, right? She's pouring them into 2, 2, 2, 2, and making all her cupcakes. How many would she get? 10, right? How'd you do that? You divide it, right? 20 divided by 2, right? Okay, so that worked out almost too nice, right? Because she has nothing left over, and in this one, it's asking how much of the mix is left over. So let's just change one of these numbers. How about we change the 2 to 3, right? Then how many cupcakes is she going to be able to make?
6.
She's going to make 6 complete cupcakes, right? Do y'all agree with that? She's going to pour in 3, 3, 3, 3. 3 times 6 is 18, but you go any more than that, you're going to need 21 ounces. We don't have that. Does that make sense? But we still can we can figure out that it's going to make 6 cupcakes by taking 20 and dividing by 3, right? 20 divided by 3, and that would give us 6 with some stuff left over. Okay, so do you understand the operation we're going to need to do? Yes? Any questions? So I'm going to take, well, let's see. We'll start this out. Elizabeth. Where's Elizabeth? That's you. Elizabeth, you're up. So what is in mathematical terms? No, you don't have to come up here. I'm not going to ask you to come up here. I just want to talk to you, that's all, okay? And I might be able to learn some names. I'm not good with names, so we'll see how this goes. Yeah, I won't learn any names, I don't think. 8 weeks, I have trouble with 16-week semesters learning names, so. What mathematical statement are we going to put up here using these original numbers now?
So 13 over 3.
13 2/3,
And so I guess we divide.
We divide that, okay? So I'll use this division, okay, instead of the fraction. And then dividing that by what?
2 over 4.
2 and 1/4. Okay, there you go. That's it. Everyone agree? That's the operation we need to do. Good, that's all I want. Now I'm going to go to the next person. Paris, is that right? Paris? Is that right? Am I saying it right? Okay. Paris, how would you handle this at this point?
Like the improper fraction.
Yeah, just change them from mixed numbers into the improper fractions or rational numbers. So we're going to do that thing we did last time where we do this times this, add this. So let's see, what would this be? 13 times 3, 39, right? Add 2, I think we got 41 over 3. And then divided by 2 times 4 plus 1, that's going to be 9 over 4. Okay, see, this is easy, right? Paris is done. Now it's Jared. Where's Jared? Okay, maybe I need to mix these up. All right, Jared, you okay with that? Up to that point, Jared? Are you all right? Okay, so what would you do at this point?
Returning to multiplication.
Turn-
flipping the
Flipping the second one, right? Now, Jared, can I cancel these? The 3 and the 9?
let's see. I didn't.
Not yet, okay? So you do not do any reducing until after you've flipped the fraction, okay? So that's kind of a danger zone there. Don't touch this yet. Now, 41 over 3, flip it, so 4 over 9. And now we're going to do multiplication. Notice nothing cancels, right? Okay, and this is just on the calculator. So let's just get on our calculator and see what we get here. What is it? You get some decimal. You get a decimal there, or is it exact? 41 times 4. So, okay, you were just giving me the numerator.
Yeah.
164 over 27. Okay, that's how many cupcakes we can make, but it doesn't really make a lot of sense to us until we turn it into a number that we can comprehend. So why don't we just do this on our calculator? Do 164 divided by 27, and we get approximately 6.074. I'll just go with that, okay? Y'all okay with that? So how many complete cupcakes can we make? 6 cupcakes, right? So the answer to the first part is 6 cupcakes, all right? Now, how much of the mix is left over? This is the trickiest part of the problem. This is the trickiest part of the problem. Because a lot of people will say that this part right here, right, that 0.074, that's how much we had left over, right, kind of? Mm-hmm. But this isn't mix. What is this? We have 6 what? Cupcakes, and then we have 0.074 cupcakes left over, right? Does that make sense or no? So this is not how many ounces of mix we have left. This is how many cupcakes we have left. So there's kind of 2 ways to go about this. I think what I'll do is, I think to make this make the most sense, we know that 6 cupcakes. Let's do this 164 divided by 27. Let's do it the old school way, right? Like this. And when you do 6 here, we know it's 6 because it was supposed to be 6, right? 6 times 27 162. We have 2 left over, right? So that means we have a remainder of 2. So we write this as 2 over 27. So 6.074 is the same as 6 and 2/27. Okay? You all still okay with that?
Okay.
So now this 2/27 is still not how much mix we have left over. That's how much of a cupcake we have left over. So we have 2/27 of a cupcake remaining. So how can we figure out how much mix that is? What if I told you I had half a cupcake, and it was a 4 ounce, it took 4 ounces of mix. Each cupcake was 4 ounces, but I have half a cupcake left. How much mix? 2, right? Half, you just multiply 4 times half. Do y'all understand that? So what we need to do is we need to take the amount of cupcake we have left and multiply it by the ounces in each cupcake. And how many ounces are in each cupcake? 2 1/4. Now, I said I would do this 2 ways. We'll show it to you both ways, and we'll get the same answer either way. So option 1 is to use the fact that we have 2 over 27 cupcakes left over, right? We take that 2 over 27 and we multiply it times the ounces in each cupcake. So there's our ounces each cupcake. We need to multiply those. So we would do the same thing we did a second ago. We would convert this into its rational form, like that, and then just multiply straight across, unless things reduce. Do things reduce? Oh, I can reduce this quite a bit. I can go 9, 3, 1, 2, right? So what am I left with here? 1/6. 1/6 what, though?
Mix.
Mix, right? So the mix is measured in ounces. So that last part is tricky. I think you would agree, yes? Because this thing that's left over is, again, is how much of a cupcake you have left over. You have to then convert that back into ounces. Okay, let me show you the second way. The second way was to just use this and do the same exact thing. So I would do 0.074 and multiply that by 2 1/4. See, the difference between these two is that this one I can do all by hand, and this one I'm going to just need my calculator to do it. So look at this as being 0.074 times 9 over 4. And so what you should probably do on your calculator is do 9 divided by 4 first. Do that. Right? You get 2.25. And then multiply that times 0.074. And you should get something like 0.1665, something like that. And this would be how many ounces you have left. Both of these answers are correct, all right? The reason they're the same, just look at that, do that on your calculator, 1 divided by 6. And you're gonna get 0.166. There's a little bit of rounding error, but this is sufficient. What do y'all think? That was a little weird, right? Okay. Make sure you understand this problem. I sent out an email right before class that has your exam 1 review on it, because remember, exam 1 is on Monday.
Okay.
So the review has been sent out, and I believe a problem like this is on that review, if I'm not mistaken. There's a cupcake problem on there. All right, so glad you asked about it. All right, what else? What was the question you had that was not, I guess, not a word problem? Okay. Order of operations. This will probably be the last one I can do right now.
So it's the one parentheses, 1/4 minus 2/3 over 2 cubed plus 1/2.
Wait, hold on.
It's that one.
This number 15? Gotcha. Okay. Can everyone see that all right? We're looking at number 15 up there. I'll go ahead and write it down here. Yeah, this one looks pretty bad, doesn't it? It's 2/3 squared over 2 raised to the third power plus 1/2 divided by 3/8. All right, order of operations. We're always going to want to do what's in parentheses first, right? So I'm going to do the 1/4 minus 2/3 first. Is it Anissa? Is that right? Am I saying that right?
Yes.
Where are you? Where are you? Okay, Anissa. If I were asking you to do this, how would you do that part right there?
You find the common denominator.
So you would do the common denominator. You would make this like 12 and multiply top and bottom by 3 here, and you go 4 here. So that little cross thing I showed you last class, you're not going to do that. That's fine. I showed you the other way if you wanted to use it. So Anissa's going to do it that way. She's going to multiply here 3, 3, 4, 4. And are you doing that mentally, or do you actually write it down? You write it down. Okay, so this will give you 3/12 here. And then minus over here, you'll get 8/12. Right? I forgot to silence my phone. I'm sorry. Let me do that real quick. And then to do this, since you have the same denominator, Anissa, what do?
You just,
Just subtract, right? So 3 take away 8 gives you -5/12, right? So that, I'm doing this on the side, right? This is like a little scratch work I did on the side. Now I'm going to come back over here. I'm going to plug it in here. So what's in parentheses here is -5/12, but then I still need to square that, right? And that negative sign on the 5, we should talk about this. This is an important aspect of fractions. When you see a negative, like we got here, -5 on top of a 12, I have a question for you. Is this the same as that? Are these the same thing or not? Is -5 divided by 12 the same as 5 divided by -12? What do y'all think? It turns out these are exactly the same, all right? Because what is a negative number divided by a positive number? It's negative, right? So this answer is going to be negative, and it's just going to be like 5 divided by 12 on your calculator, make it negative. This one is same thing, positive over negative, so you still get a negative answer, and it's still 5 divided by 12. So these are exactly the same. What I'm trying to say to you is that when you have a negative in a fraction, you can leave it on top, or you can move it to the bottom. It's up to you, all right? And you can also put the negative out in front of the fraction like that, and that is the same thing. All right, all of these are the same. So just remember that with a negative on a fraction, it floats around. It can float around, top, bottom, or out front. And you'll see me when I write things. Sometimes I almost did it here. I almost put the negative out here, and then that may have confused you. Yes.
What's the difference if you put it out there?
There is no difference. That's what I'm saying. They're all the same. Okay, they're all the same. The reason why I wanted to mention it to you, though, is because we're going to need to square this, aren't we? And didn't we talk about last class, like there's a major difference between -2 squared versus -2 in parentheses squared, right? Like this is 4, that's -4. So this, I was going to ask you the question, that's what made me think of that. When we're here, okay, when we're here, this negative is going to get squared, right? So this, when we're done, is going to be a positive answer. And the way you can see it is, the negative is really kind of out here like that, and then it looks very much like this, doesn't it? Okay. So, continue. That was me just rewriting this over 2 to the third plus 1/2 divided by 3/8. All right, so I've taken care of parentheses. Have I taken care of parentheses? I still see a parentheses. Have I taken care of everything in parentheses? Pardon?
Yeah, square.
Yeah, I have done what's in parentheses, right? So there's nothing more that I can do inside of this parentheses. So I move on to the next thing, which is exponents. And I actually have two exponents. I have it here and here, right? So I'm going to do these at the same time. Just going to square the top and square the bottom, and we'll move that over here. So this is equal to, moving over here, this is equal to, all right, what happens when you square the oh wait, hold on. Alyssa, where's Alyssa? Alyssa, going to square this right here. So what would you get when you square that?
I got 25 over 144.
25 over 144, and it's positive, right? Okay. You want to keep going? Tell me what the bottom is.
The 2.
2 raised to the third? Uh-huh.
got
8. So that's just 2 times 2 times 2, right? So we've got 8 here, and then we'll just rewrite everything. Don't be worried about wasting paper, all right? There's no... Are y'all worried about that? Are y'all worried about wasting paper, running out of trees? Are y'all worried? You should be worried about more bigger things than that. My wife caught me a few years ago recycling. She caught me throwing the recycle away with the trash. She got all mad at me. And I had a debate with her that I believe that it costs more money to recycle than, it consumes more energy to recycle than it does like what you save. Does that make sense? Think about the trucks have to come through your neighborhoods, pick up all your recycle, right? They have to sort through all this stuff. At the end of the day, is what you save. Am I making sense or not? People don't believe me. People don't believe that, but I actually saw something on the news the other night about somewhere, I think it's Castle Hills, or they've asked people to cut back on their recycling because it's costing too much money and energy. And think about the pollution of the trucks driving through the streets just to go pick up your milk jug, right? Okay, what am I talking about? I'm going off on a random tangent here. And at the end of the day, right, at the end of the day, the ultimate recycling is going to take place. When our sun expands and dies, the sun will expand and the entire earth will be pretty much vaporized and everything on it will be recycled. So it's, it's futile. Y'all don't like that attitude, do you? All right, what next? Gabriella? What? Okay, do we have 2? Do we have 2 Gabriellas?
Oh, you said Gabrielle.
Oh, okay, you're not Gabriella. Okay. All right. What did you hear? Your name? Brianna. Okay, I need to clear my throat. Okay, Gabriella. What do I do next?
Divide.
Which division? I see 2 of them.
The first.
So you actually can do either one, okay? Now, normally we move left to right, so we'll start with this one. Now, when you see that, Gabriella, that's kind of tricky. I don't know if it's tricky or not, but what do you see there? 25 over 144 divided by 8. How are you going to divide that?
Turn the 8 into a fraction.
Okay, good. So you're realizing that 8 is like 8 over 1. And this we talked about last class also, how important this division bar is. Remember I said one of those has to be bigger? So you see that. You see that you have a fraction over a fraction. So, Gabriella, I'm going to write down the next line because I think this is where you are. Is that kind of what you're thinking? You may have done it a different way. Now what? Flip this, right? Flip that over. So I'll do that. See, I'm wasting paper. Doesn't matter. Is that too pessimistic of an attitude to have? That it's all going to get vaporized at the end by the sun? Is that, yes?
Can you just flip the 8 over 3 now?
Oh, you want to flip it now? Sure. Does anyone object? Anyone have it? You want to you don't want to waste paper, do you? Okay, all right. That's fine. I'm just trying to show like every little detail, all right? Okay, so now at this point, Brianna, You happen to be the next one. That's weird. Do you think that's weird? She just happened to be the next one? Does that not strike you as being odd? No? What are the chances of that? Probably like 1 in... I feel very random today. Let's keep going. What do you want to do? So you're going to do all the multiplications first, right? You're not going to touch that addition, right? Because multiplication now, when you multiply, you're going to do these two? You want to do these, or you want to do these? Or you want to do them both together? It doesn't matter, right? Yeah, so basically we can do this and we can do this. We'll save some paper. We'll do them both at the same time. Brianna, does anything reduce? Or are you just going to like multiply and not even check? Like, do you want to check that, or do you just want to go?
The first one doesn't,
Yeah, the first one doesn't look like it does it?
the second one, you can't.
Second one, 2 and 8. You want to do that? We can do that. Okay, I'll make that 2. 2 goes in 2 once. 2 goes in 8 4 times. All right, so we're going to get some big numbers here, aren't we? Okay, so 25 times 1. 25. Brianna, do you have a calculator or no? No? You didn't do this one, did you? No. Go ahead, someone else. 144 times 8. 1,152. Ugh. Okay. And then over here, what do we get when we multiply across over there? Because we have a plus between them. Is that 4/3?
Yes.
4/3. Golly, this is nasty. That is a horrible, horrible looking fraction over there, isn't it? So now you need to add these together. Is it Jameson? Mm-hmm. Are you keeping up with us right now?
Yeah.
I'm just going to ask what you would need to do to add those together.
Find a
Common denominator. And is that going to be easy? I don't know if that's easy. I mean, that could be a very, very ugly denominator, couldn't it? Maybe if we're lucky, this number is a multiple of 3. Is it? How would you check? Get your calculator out and do 1152 divided by 3, and what do you get? 384? Oh, we got lucky. Okay, we got lucky. So what we're going to do is multiply. I'll do it on next line. We're going to multiply 4 over 3 times what? 384 on the top and bottom, right? And that will allow us to get our common denominator. Now, what if it wasn't? What if there wasn't a number? This was not a multiple of this. I personally would just do this, and then straight across that thing I showed you last. That's what I would do. If this didn't work, I would just resort to the other method. All right, so we have 25 over 1152 plus, 4 times 384. Who's got that?
1,536.
1,536 over 1152. Oh, equals. And we're ready here. Add those together, right? So 1561 over 1152. I believe that's what we're getting. A lot of steps there, right?
Mm-hmm.
All right, so is this the answer in the solutions? It is? They left it like that?
Yeah, it's weird because I got the same answer without reducing the 8 over 6.
Without reducing the 8 over 6. What 8 over 6?
I mean, or the 1 over 8. No, yeah, the 8 over 6. Yeah, the 8 over 6. I got that same answer without reducing.
What 8 over 6 are you talking about?
Well, when you got
Oh, yeah, you know how, when we flip this one?
Yeah.
And, we should always get the same answer.
Okay.
Yeah, even if you reduce, because you're reducing the top and bottom by the same thing.
Okay.
So it doesn't change the problem. This is what makes math great,
Yeah.
is that, as long as you follow the rules, we're all going to wind up with the same answer,
Okay.
right? We don't want 2 different answers, right? That wouldn't be good, right? One engineer is building a bridge, doing the math his way, and another one is doing it her way, and then, you know, come together and it falls down. Okay. That okay? Yes? Okay, you mean like a mixed number? Yeah, okay, so I think someone emailed me or texted me about this. I am completely happy with you leaving it just like this. You do not have to switch this over into a mixed number. All right, just leave it like that, we're good. If you want to change it to a mixed number, go ahead. All right, that's no problem with me. All right. All right, so I think we need to move into the material. If you have any other questions on this, you know, send me a text or something. And don't forget about the tutoring lab. You know, we didn't talk about their hours, but they put them up there. I think they're open till 9 o'clock every night. And it looks like they open at 8 a.m. on Monday, and on Tuesday through Thursday, they're open at 7 a.m. So that's a lot of hours over there. Unfortunately, they're not open on the weekends, but if you need help, you know, they have the packet, they know how to get to the answers, they can help you out. All right, we are moving along. Solving linear equations. So we went and talked about that, yeah. We were talking in class about my utility bill, right? But we never really got to solve any of the problems from here. So we need to do a couple of these. Oops. Yeah, that'll work. So when it comes to solving linear equations, I want to just kind of write out a few steps so we understand what the process is. Steps for solving linear equations. And we should make sure that we understand what a linear, can you throw me that blue marker? Just throw it. Okay, thank you. We need to understand how important these words are in the problem. So first of all, the word equation means that when we're looking at this thing, it has what in it? No, equation. The word equation means you have an equal sign. Okay, if you look at the problem we just did before, there was no equal sign, right? Just gave you an expression, told you to simplify, and we did all the work, we got an answer, right? So here, we actually have an equation, which means we are trying to figure out solutions to this equation. And we are solving for what's called the variable in the problem, which is x, all right? So right now, we are looking at an equation. It has the variable in it, x. Now, why is this word linear here? What is that word? Okay, so that means somehow it's related to a line. But in terms of our variable, notice that this variable isn't squared, right? It's not like x squared or x cubed, or it's not the square root of x. It's just x by itself, right? Really, it's kind of like we have x raised to the first power, right? Isn't that what x is? X to the first power. Whenever you have an equation with a variable in it that is raised to the first power, it is called a linear equation. Later on, we will be solving quadratic equations where it will be squared, and then the steps are completely different. All right, so we need to know what you're looking at before you can start trying to solve anything. So we have equations here. These equations are linear, and therefore we will follow a procedure. If you like procedures, I'll give you the procedure, all right? So here's the first step, okay? Make sure it's linear, all right? That's just a reminder. Make sure it's a linear equation, all right? Then you can use these steps. Second thing, does anyone know what the steps are for solving a linear equation? Does anyone know what the main goal is when we solve a linear equation? Get x by itself, okay? Get x by itself on one side of the equal sign. Doesn't matter which side. Turns out it doesn't matter which side, okay? So that will be our ultimate goal, but how do we achieve that goal? So The first thing we do after we know what we're looking at is we simplify each side. And what I mean by that is remove parentheses, exponents, etc. In other words, if there's anything that's keeping stuff clumped together, get it all so it's all spread out and there's no parentheses or exponents or anything like that. And you do that on both sides separately. So you can see, like, for step 2 on this first one, like, I'm not happy here. You see the parentheses? I need to get rid of that parentheses. So we will do that, all right? That'll be our second step. The third step is to do what's called collecting like terms. So anything that is the same type of thing, you put together. So if I have like a 2x and a 3x being added, I put them together to get 5x. If I have 7 minus 4, I subtract and I get, 7 minus 4 is 3. And I do that individually on both sides, all right? And then the last kind of, we're getting there, yeah. Move x terms to one side. All right, so I should have just said isolate the x term. Same thing. Move the x term to one side. And when we do this, we are going to be using addition and subtraction to do that. And then my fifth step, sorry, I'm going to go off the camera here, but I'll just put it up here. The fifth step will be to use multiplication or division to get 1x. So these are the steps. When we move through the example, you'll see it come to light, all right? All right, so let's do this first one. We have 5, and then parentheses x minus 2, and then equals 4x minus 10. So first step, make sure it's a linear equation. So look at it. I see equal sign. I see x raised to the first power, so I'm good. So now I'm going to simplify each side. And Aaron, where's Aaron? Right there. Aaron, I kind of alluded to this already, Aaron, but what would be the next step then? Distribute. That's the correct language we use. We distribute the 5 through the parentheses. So we distribute, multiply here, multiply there, right? Y'all seen that before? Okay, so we would get, Aaron, what here?
5x minus 10.
5x minus 10. Why is it minus 10?
Because the 2 is negative.
Yeah, so negative 2 times 5, negative 10, all right? And then the other side, there's nothing to do on the other side, right? There's no parentheses, nothing to simplify? Okay. Miranda. I know Miranda's here. Okay, Miranda? What would be our next step here? I think we're on 3, right? So is there anything that we can collect that are like terms on each side individually? So can we put those two together? No, because one of them has an x, the other one doesn't. Over here, Miranda? No, can't put any of those together. So step 3 here for us, we didn't have to do, right? All right, so now, go ahead, Miranda. I'll let you keep going.
I would move the 4x to the left.
So you're going now to move the x terms to one side. You're choosing to try and move all your x's to the left side. Okay, that's fine. And so you said you want to move the 4x over here. How are you going to achieve moving the 4x over to the other side? Subtracting it, right? So you see a positive 4x here. So you have to subtract a 4x here and subtract a 4x here. Okay, that will get these to cancel. So you won't have x's over here, right? But Miranda, you're still going to have a minus 10 over here.
Yes.
And so how would you take care of having the minus 10 over there? Adding it, right? Adding 10. I'm pretty sure most of you have done this in your life, okay? So I understand this is still like review here, but we just want to make sure we can do this, because if we can't do this, you got to crawl before you walk before you run, all that. All right, so does everyone understand why I decided, or why Miranda decided to get rid of the 10 here and take it to the other side? That'll get all my x's over here, and everything that's not x goes over there. All right, so what do we get here at the end of the day here? 5x take away 4x is just 1x. Now, whenever we get 1x, I'm just going to write x. And then equals, and then over here, 0. Negative 10 plus 10 is 0. Now, the good thing about equations is that you can always check to see if you got the answer right. Like you can check to see if you did it right. How would you check it? Go back to the original problem and plug 0 in for x. So you don't have to check these, but I'm just going to show you it will work. So if I do this, let's see. What's in parentheses first? 0 take away 2 is negative 2. 5 times negative 2 would give me negative 10. The question is that equal to this side? Well, 4 times 0 is 0, it's gone, and you have negative 10. So it is correct. All right. So obviously these just get harder and more complicated, right? So let's do something that's more complicated. So I'll look at one here. When I first started college, I was an architecture major. I wanted to do architecture. And then at some point, I decided I wanted to do physics because I wanted to change the world. I wanted to change the world. Physics, I felt, would be the best place for that to happen. And then I realized that in our society, we don't put a lot of value on research and things like that. And there's not a whole lot of money in physics. Not to be made. I'm not talking about making money. I'm talking about research. It takes a lot of money to get to that next level in physics to figure out like all the things that are happening atomically, in very small things. It takes a lot of money. My point is, I'm talking about the sun expanding and being real pessimistic. It's because I realize that our culture values the wrong things. We are going to run out of time on this planet. It's going to happen. We're just going to run out of time. And it's already happening. People can complain about global warming and all that stuff. And it's because we don't care enough. What we value are what? What do we value? Social media?
Or narcissistic society.
Yeah, think about this. Think about a professional athlete. I did a calculation a couple of months ago. There's a pitcher, I think one of the highest paid pitchers, professional pitchers. You know how much he makes every time he throws the ball? One pitch. Not quite 500,000. No, that's a little. I'm talking over the whole season. Every pitch, every single pitch he throws is like 40 grand. Can you imagine that? Just think about that. Guy stands up there, throws a ball. Now he throws the ball probably faster and better and all that than anyone else in the world. Who cares, right? But that's like people's entire year income in one throw of a ball. That's what we value in our society. We value these things. What we don't value is the 18-year-old in a college sitting there in a lab wanting to change the world. We don't value that. Does that make sense? So I don't recycle because our society doesn't care enough. It's a joke. We're just trying to pat ourselves on the back. Look, we're trying. We're not trying. Okay, I'm getting way too political. I'm sorry. Okay. 10, I guess I only share it with you because you all are the generation that has to make the difference. You know? Like, you have to care enough and put values on things that will ensure the survival of the species, unless you're expecting that at some point some divine thing is going to come and save you. If that's your belief, that's your belief, and I'm not trying to belittle that, but until that happens, you know? Okay. That looks a little bit uglier, doesn't it? Who's up? Let's see here. Marcus. Okay, Marcus. First step is to make sure it's a linear equation. Does that look like a linear equation to you, Marcus? Yes? Equal sign, x is all to the first power. We look good? So, Marcus, what will you do now that we have the
Take care of the
parentheses? Okay, so let's look at that first one, Marcus. How am I going to get rid of this parentheses here?
distribute the -1.
-1, I don't see -1.
Oh, negative.
It is a -1. Good, Marcus. So you realize, Marcus, that this is a -1. All right? So everyone needs to realize that. That's a -1. And that -1 will pass through the parentheses. Marcus, can I go ahead and take care of this parentheses also? Sure, right? Because it's on the other side of the equation. I can go ahead and handle that now also. So I'm going to clear all my parentheses out. Marcus, you're on a roll, so let's just keep going. What would I get here, Marcus, if I...
It's going to be 10x minus 4 plus 3x.
Plus 3x, right? Okay, very, very important. Make sure that's a plus 3x. Those are those little things that people mess up on tests, right? They put minus 3x because they forget negative times negative is positive. All right. Other side, Marcus, you're almost done.
7x plus 6x plus 10.
Do we all agree with Marcus? All right, good. All right, this is interesting. Nivini? Am I saying that right?
Yeah.
Nivini. I don't think I've ever seen that before. Nivini. What would be our next step?
Can we combine the 10x and the 3x?
Yes, we can. I will allow you to. The mathematics says yes, that is our next step. We're going to put those two together. 10x and 3x, what does that give us, Nivini? 13x, and what about that minus 4? Just keep it there. Just leave it alone. Equals, and then now the right side, you can keep going. 13x, so put those together. That's 13x. And then plus 10? Okay. I see what's going to happen here, but I'm not going to make Nivini do it. I'm going to do, is it Devon?
Yes.
Yes? Where are you at? Okay. You're up, Devon. Do you know what the next step is? Combine like, that's what we just did. Okay, so what we just did was combine like terms. Nivini did that for us. Put these together, put those together. Now,
Put it with x to one side.
get all our x's on one side. So,
So minus 13.
okay, so you're going to choose to get this one over there. So you're going to subtract it because it's a positive. So you subtract 13x here. You subtract 13x there, right? Now, while you're doing that, why don't you take care of this side also, because you don't want this over here, right?
Right, so plus 4.
Plus 4. Good. Both sides. Right?
X equals 14.
Is it x equals 14? 13x take away 13x is nothing, right? This is 0. And negative 4 add 4, that's 0. This left side of this equation is 0, isn't it? Okay. 0 equals, and then that side, these went away, and you get 14. What? So I'm here to tell you today that 0 equals 14, right? No. What does that tell you? That means there's no solution to this equation. There is no solution. All right? So I'll give you an easier equation to look at. Okay, look at this real quick. If you look at that equation, can you just look at that and tell me what the answer is? 2, right? X is 2. Agreed? Okay, so that has a solution. Now I want you to do this equation. Can you look at that and tell me what x can be? What x would be to make that true? 0 wouldn't work because 0, that would make it 1 equals 0, wouldn't it? Will 2 work? Then that'll be 3 and that'll be 2, right? There's nothing, you can sit here all day long. You can spend the rest of your life looking for a solution to this. You will never find one, okay? And the reason is because if we follow the procedure, I would subtract x, right? And then I would get, what over here, 1? And over here I get 0, and 0 is not 1. So this is telling me right here, this is telling me, look, there is no solution to this equation. That's what this is telling you. So you say here at the end, no solution. All right? No solution. Now this may happen in your homework. So just put no solution. But there may be something else that happens in your homework where you work through a problem and at the end you get something like this. The x's cancel, but you get something like this at the end. So here we got 0 equals 14. We know that's not true, so there's no solution. What if you work through a problem on your homework and you get at the very end 4 equals 4? What is that telling you? Well, that's telling you that every number is a solution. All right? Every number is a solution. Do you want to see an example of that? Or I can show you an example of that. How can I do this? X plus 1 equals 3x plus 6. 3x plus 3. Wait a minute, hold on. That's not what I want. It's really hard to come up with one of these that's not so obvious. Let me come up with this one. How about this? 2 times 2x minus 1 equals 4x minus 2. All right. So there's an equation, right? I'm going to work through this very quickly. Linear equation. If I multiply this through, I get 4x minus 2 equals 4x minus 2. Do you all agree? Now at this point, if I subtract 4x here to get everything to one side, you can see my x's are going to cancel, aren't they? And I'd be left with here the negative 2 and negative 2. So negative 2 equals negative 2. And this would mean that every x is a solution to this. So we go back to the original equation. Give me any x, plug it in here, and it'll work. So if you plug in 5 and 5, it'll work. If you plug in 10 and 10, it'll work. If you plug in 1,000,000 and 1,000,000, it'll work. All right? So just be aware of that. You would put here all real numbers. Numbers. Okay. All right, let's look at something like number 25 because it has fractions. And I know you love fractions. I know you do. I should make another comment. I think I will. But I think if you just listen to what I said about the pitchers and the money they make and athletes and stuff, you would get the impression that I don't like sports. I do like sports. I actually think that sports in our society keeps us from being crazier than we already are. I mean, there are a lot of people that look forward to their weekends, to the football season, to baseball. But, I mean, there's a lot of people who really enjoy sports. And I can't imagine living in a society where we didn't have that outlet, you know? People are already crazy, but... All right, we haven't talked about a problem like this because it has fractions. And in the set of steps, I did not talk about fractions at all, did I? So, do you know on that step number 2 where I said simplify, right? Remove parentheses, what did I say?